BSc Chemistry Surface Coatings presented by Dr. Giridhar M, Assistant Professor of Chemistry, Department of Collegiate Education. So in this session we will be studying pigment, PVC, that is paint volume concentration, paint failure, toners and lakes. So in the previous session I had told that paint consists of pigment, vehicle or binder, pigment, thinners, dryers and other constituents. So we have already discussed the properties of binders or vehicles. So in this session we will be studying pigments and its properties. So the constituent of this session are pigments, function of pigment, characteristic of a good pigment, pigment volume concentration, paint failure, toners and lakes. So let us start with pigments. Pigments are colored substances, solid colored substances which are bound to surface with the help of binder. It is major constituent or ingredient, that is 70 to 80% of a paint constitutes about pigment. So of an oil paint, both inorganic and organic substances can be used as pigment. So as the definition tells, pigments are solid colored substances. That means these are insoluble substances which are present in the paint and impart color to the paint. Functions of pigment. So it provides color and strength to paint. As I already told, these are colored materials and therefore they provide color and hence strength to the paint. So impart an aesthetic appeal to the film, give protection from harmful UV light. So since these pigments are opaque in nature, they protect from harmful UV light. It provides resistance and improve permeability of paint films. So resistance to corrosion, resistance from oxygen, contact between metal and oxygen, this can be achieved with the help of pigment. To reduce the loss and weathering property. So these were some of the properties of pigments. So classification of pigment. So pigments may be classified as natural or synthetic. Natural means pigments obtained from plant source, flowers, bark of a tree. So these are nothing but coloring substances which are obtained from natural source. Or synthetic, they can also be prepared in laboratory. It can be organic or inorganic. So inorganic means here it can be metal salts, say for example barium sulfate, which is white in color, potassium chromate, which is yellow or orangish in color. Similarly, it can be organic in nature. So that means some organic compounds which are having colored, okay, they can be used as pigments. So on the basis of color also we can classify, like white colored pigments, blue colored pigments, yellow colored pigments. So this is how we can classify pigments. So next we will see characteristic of a good pigment. What are the characteristics of a good pigment? Good covering or hiding power should be there. So that means when we apply on the surface, good covering property should be there for the paint. Chemically inert, it should be chemically inert and weather resistant. So it should not degrade in heat, okay, or bad weather. When it is rainy days, it should not undergo hydrolysis. So it must be chemically inert. For a long life, it must be chemically inert and weather resistant. It must be non-toxic. And color fastness should be there. That means color should not fade over the time. So these are characteristic of good pigment. Should freely mix with film forming constituent, that is, it must freely mix with binder or vehicle, that is oil, and it should also be reasonable cost. So that means pigment should be cheap, because 70 to 80% of a paint constitute of pigment. If pigment becomes costlier, then the cost of paint will also go higher. So therefore it must be of reasonable cost. And finally, as already told, this pigment should be have opacity. So if it is transparent, then there is no question of covering or hiding power. So transparent means, so it must be opaque so that it will cover the surface on which it is applied. So next we will move to examples of colored pigment, some of the examples. So these are some of the examples. Say white. So white color, we have white lead, lead hydroxide. Nowadays lead is poisonous substance, so these are very less used. Zinc white, so ZNO. Lithophane, that is ZNS plus BaSO4. Titanium dioxide is white color powder which can be used as pigment. And these are white color paints. Similarly, we can find creamy white, that is zinc sulfate. Zinc sulfide is used as creamy white for creamy white color. And yellow color, chrome yellow, zinc chrome, barium chromate, cadmium sulfide, all these are yellow color. These are inorganic substances, these are inorganic pigments. Green color, permanent green. Blue color, Persian blue is there, ultramarine blue is there, cobalt blue is there. These are the different blue color and its constituents are given here. Red color pigments, vermilion, vermilion, chrome red, different varieties of red colors are also available. And then maroon color, black color. For black color we use copper chromate, manganese dioxide. Lamp black is nothing but carbon, it is carbon. So these are some of the examples for colored pigments. So these are inorganic pigments. So there are number of organic pigments which do not have same heat resistance as inorganic ones. So as we know, organic compounds are they have very low melting point, and also they undergo charring at high temperature, and therefore at high temperature they are not resistant to heat. Some of organic pigments, while being satisfactory for interior use, are not suitable for exterior paint, since they are sensitive to light and will consequently fade. So as I told, they are not heat resistant, therefore we cannot use this organic paint outside where sunlight falls, as a lot of heat is generated because of that, and also the paint itself is sensitive to light, and consequently the color will fade with time, and therefore these organic pigments are only used for interiors and they are not used for exteriors. So some metal powders are used as pigments in certain paint. So the most widely used metal powder is aluminum. So aluminum paints are popular because of the resistance to corrosion. So as we know, aluminum corrode slowly when compared to iron, and therefore we can consider them as it is resistance to corrosion. See, the other reason is this aluminum can form a film of oxide on the surface, and this film sticks tightly to the surface, whereas in case of iron, peeling will take place. So that means the corroded surface goes on peeling and new surface comes into contact with air and moisture, and therefore there will be continuous corrosion. whereas in case of aluminum, an initial formation of a surface of oxide film protects the inner aluminum. So therefore aluminum is less prone to corrosion. So and also it is resistance to corrosion, durability is there, high covering power, they are brilliance in color, and they are also non-toxic in nature. So that is why aluminum paints are used in most of the cases. So next we will move to pigment volume concentration. Pigment volume concentration, in short we can say PVC. PVC is defined as volume of pigment in the paint divided by the sum of volume of pigment in the paint. So that means it is the fraction of volume, okay, fraction of volume compared to total volume of the paint. So that of non-volatile vehicle constituent in the paint. So PVC is defined as the volume of pigment in the paint divided by the sum of volumes of pigment in the paint and that of non-volatile vehicle constituent in the paint. So the formula is given as PVC is equal to volume of pigment divided by volume of total solids. So that is Vp divided by Vp plus Vb. So Vp is volume of pigment divided by total volume. So volume of pigment plus volume of binder. So this is pigment volume concentration. Paint failure. Why does a paint fail? Why does it fade away or it crack? Peeling will take place in some cases. So this is called as paint failure. The failure of paint may be ascribed to following reasons. First reason is destructive oxidation of oil after the drying of the paint on the surface causes chalking or powdering, which leads to the erosion of paint. So that means here binder or vehicle undergoes destructive oxidation forming powder like substance. Okay, that is, it is not stable on the surface, it will form powder and powder ರೀತಿಯಾಗಿ ಉದುರೋಗುತ್ತೆ. Okay, so over time, so that is called as destructive oxidation, due to destructive oxidation. Presence of dirt, grease or water on the surface to be protected results in poor attachment of paint and consequently surface coating flakes or peels. ಸೊ ಅಂದರೆ ಪೇಂಟ್ ಅಪ್ಲೈ ಮಾಡಬೇಕಿದ್ರೆ ಸರಿಯಾಗಿ ಸರ್ಫೇಸ್ನ ಕ್ಲೀನ್ ಮಾಡಲಿಲ್ಲ ಅಂದರೆ, ಉದಾಹರಣೆಗೆ ಡರ್ಟು, ಗ್ರೀಸು, ವಾಟರ್ ಇವೆಲ್ಲ ಇತ್ತು ಅಂದರೆ, then that binder will not attach to the surface properly and that leads to formation of peel ಅಂದರೆ ಸಿಪ್ಪೆ ಸುಲಿಯುತ್ತಲ್ಲ ಆ ರೀತಿ ಸುಲಿಯುತ್ತೆ, ಅಥವಾ ಫ್ಲೇಕ್ಸ್ ಹಂಗೆ ಹಾಗಾಗಿ ಉದುರೋಗುತ್ತೆ. ಸೊ ಅದನ್ನೇ ನಾವು ದಿಸ್ ಇಸ್ ದ ಸೆಕೆಂಡ್ ರೀಸನ್ ಫಾರ್ ಪೇಂಟ್ ಫೇಲ್ಯೂರ್. ಆ್ಯಂಡ್ third reason is absence of plasticizers in the paint causes fine surface cracking or checking. ಅಂದರೆ ಪ್ಲಾಸ್ಟಿಸೈಸರ್ಸ್ ಏನು ಆ್ಯಡ್ ಮಾಡ್ತೀವಿ ಪೇಂಟಲ್ಲಿ ಅದು ಇಲ್ಲದೆ ಹೋದರೂ ಕೂಡ ಕ್ರ್ಯಾಕಿಂಗ್ ಕ್ಯಾನ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್. ಓಕೆ, ಸೊ ದೀಸ್ ಆರ್ ದ ರೀಸನ್ಸ್ ಫಾರ್ ಪೇಂಟ್ ಫೇಲ್ಯೂರ್. ಸೊ ನೆಕ್ಸ್ಟ್ ಅದರ್ ಟರ್ಮ್ಸ್ used to describe paint failure are allograting. ಸೊ allograting ಅಂದರೆ ಸೆಂಟರ್ ಪೋರ್ಷನ್ ರಿಮೈನಿಂಗ್ ಇಂಟ್ಯಾಕ್ಟ್ ಆ್ಯಂಡ್ ಪೋರ್ಷನ್ ಅರೌಂಡ್ ದ ಸೆಂಟರ್ ಪೀಲ್ ಆಫ್. ಸೊ ಮಧ್ಯದ ಪೋರ್ಷನ್ ಹಾಗೆ ಇರುತ್ತೆ, ಸೈಡಲ್ಲೆಲ್ಲ ಪೀಲ್ ಆಗುತ್ತೆ ಪೇಂಟಲ್ಲಿ. ಬ್ಲಿಸ್ಟ್ರಿಂಗ್ ಅಂದರೆ ಬೊಬ್ಬೆ ಬರೋದು, ಬೊಬ್ಬೆ ಕನ್ನಡದಲ್ಲಿ ಹೇಳಬೇಕಂದ್ರೆ ಬೊಬ್ಬೆ. ಸೊ ಅಪಿಯರೆನ್ಸ್ ಆಫ್ ಬ್ಲಿಸ್ಟರ್ ಆನ್ ದ ಕೋಟ್ ಅಂದರೆ ಬಿಸಿಲೆಲ್ಲ ಬಿದ್ದಾಗ ಬೊಬ್ಬೆ ರೀತಿ ಊದುತ್ತೆ ಪೇಂಟು. ಓಕೆ, ಬ್ಲೀಡಿಂಗ್. ಸೊ ಬ್ಲೀಡಿಂಗ್ ಮೀನ್ಸ್ ಡಿಸ್ಕಲರೇಷನ್ ಆಫ್ ಪೇಂಟ್ ಅದರ ಕಲರ್ನ ಕಳ್ಕೊಳ್ಳೋದು, ಅದಕ್ಕೆ ನಾವು ಬ್ಲೀಡಿಂಗ್ ಅಂತ ಕರಿತೀವಿ. ಸಿಸ್ಸಿಂಗ್. ಓಕೆ, ರೆಫ್ಯೂಸಲ್ ಆಫ್ ಸಮ್ ಪೋರ್ಷನ್ ಆಫ್ ಸರ್ಫೇಸ್ ಟು ಗೆಟ್ ಪೇಂಟೆಡ್. ಓಕೆ, ಸೊ ಕೆಲವು ಸರ್ಫೇಸ್ ಏರಿಯಾ ಓಕೆ ಪೇಂಟ್ ಅಟ್ಯಾಚ್ ಆಗೋಲ್ಲ, ಸೊ ಇದಕ್ಕೆ ಬ್ಲೀಡಿಂಗ್ ಅಂತೇಳಿ, ರೆಫ್ಯೂಸಲ್, ಓಕೆ, ಸಿಸ್ಸಿಂಗ್ ಅಂತೇಳಿ ಕರಿತೀವಿ. ಸೊ ದೀಸ್ ಆರ್ ಆಲ್ಸೋ ಸಮ್ ಟೈಪ್ ಆಫ್ ಪೇಂಟ್ ಫೇಲ್ಯೂರ್. Paint failure may be minimized by how to minimize this paint failure. One is before applying paint, properly cleaning of the surface. Okay, that is what in the first session we have studied, preparing surface for preliminary treatment of surfaces. Careful mixing of ingredient as per specified condition. So ಇಲ್ಲಿ thinners ಅದೆಲ್ಲ ಪ್ರಾಪರ್ ಪ್ರಪೋರ್ಷನಲ್ಲಿ ಮಿಕ್ಸ್ ಮಾಡಬೇಕು. ಈವನ್ ಇಫ್ ಯು ಆ್ಯಡ್ ಮೋರ್ ಥಿನ್ನರ್, paint will become dilute, pigment will become dilute. Using primer coat before application of paint. So primerನ ಅಪ್ಲೈ ಮಾಡಿ ಆಮೇಲೆ ಪೇಂಟ್ನ ಅಪ್ಲೈ ಮಾಡೋದು one of the method for minimizing paint failure. Okay, next we will move to toners and lakes. So toners, insoluble organic dyes are known as toners and can be used as pigments. So usually these are dyes, organic dyes. Okay, so they are quite durable and have high coloring power. So example, para red, okay, and then Hansa yellow G, toluidine toner. So these are some of the examples, and this para red is prepared by diazotization. So diazotization of para-nitroaniline and coupling it with beta-naphthol gives para red. So similar lakes, organic dyes are adsorbed on inorganic substances, so such as clay, barite, aluminum hydroxide are called lakes. So these are also organic dyes, okay, but they are absorbed on inorganic substances, so which also find use as coloring material in paint. So example, once again, para red and Hansa yellow G are also used as lakes. Dryers accelerate the drying of film by suppressing the action of antioxidants in the film. Okay, examples for dryers are naphthalene, linolates of lead, manganese and cobalt are some of the examples for dryers. So as we have already discussed, so in the properties of binders, so what happens, the mechanism of drying of film is formation of hydroperoxide linkages of oils in the presence of oxygen. So if antioxidants are present, that process is not possible and hence drying will get slower. When we add dryers, okay, they suppress the action of antioxidant and thereby they encourage formation of reaction of oil and air or oxygen to increase the or accelerate the process of drying. So this is the properties of dryer. So this is toners, lakes and dryers. References. Thank you.